We are moving on with Chapter 7, Ionic Compounds. Okay, in the first section, we are going to learn how ions are formed, and this should be a review from physical science. Then in Section 2, we're going to learn how those ions bond together to make compounds. And then Section 3 is my favorite. We get to learn how to name those compounds and how to write the formulas for those compounds. So the big idea for this chapter is atoms in ionic compounds are held together by chemical bonds formed by the attraction of oppositely charged ions. Objectives for Section 1. Define a chemical bond. Describe the formation of positive and negative ions, and relate ion formation to electron configuration. We are going to use the information that we've learned in chapters 1 through 6 to help us learn more about these chemical bonds. Remember that we have talked about chemical reactions being the atoms trying to get to the octet rule. They want 8 electrons in that valence electron or that outer shell. So remember, octet rule, atoms tend to gain or lose or share electrons in order to acquire 8 valence electrons. New vocab, we have chemical bond, cation, and anion. And the main idea for this particular section, ions are formed when atoms gain or lose valence electrons to achieve a stable octet electron configuration. Okay, remember we said that when we have a chemical reaction, we start with reactants and they break apart and recombine with each other to make a new product. They have to chemically bond together. So a bond is the force that holds those atoms together. Chemical bonds form by the attraction between a positive nucleus of one atom and the negative electrons of another. So we need to have positives and negatives come together to make that bond. Remember that it is the valence electrons only that are involved in the chemical bonds, so those outer shell electrons. Okay, atoms try to form the octet, the stable arrangement of 8 valence electrons in the outer energy level by gaining or losing valence electrons. Okay, we had your periodic table. You might want to pull that out and look at it. We had written across the top of the periodic table everything in group 1. In group 1, remember we had a +1 written up here. That means that there's 1 electron in the valence, my mouse is going away. 1 valence electron. Group 2, there are 2 valence electrons. Remember, we skipped the transition elements and went to group 13. There are 3 valence electrons, so we had a +3 written up here. Group 14, +4. There are 4 valence electrons, and then so on and so forth. Now we get to group 15. We have 5. Remember, this was a +3, or excuse me, a -3. 16 is a -2. 17 is a -1. 18 is a 0. And we will get to what those numbers mean here in a minute. But remember this chart with the number of valence electrons in each group. Okay, the very last part of, I believe it was chapter 6, we talked about these different vocabulary. Ionization energy, we're going to need these vocab, so we need to review them. Ionization energy refers to how easily an atom loses an electron. Electron affinity indicates how much attraction an atom has for electrons. And the noble gases. Remember, noble gases, they're happy. They have 8 in their outer shell. They don't want to combine with anybody else. So remember, they have a high ionization energy and a low electron affinity. And that does make a difference. The ionization energy and the electron affinity makes a difference with who combines with who to make the compound. Okay, so let's talk about a positive ion. They call that a cation. Um, how I remember that is cats are positive, I guess you could think of it that way. So a cation, cats are positive. They like to get mice, so they're positive to have around. You can look over here. This figure illustrates how sodium loses one valence electron to become a cation. So you have 11 electrons, 11 protons. It loses one electron, right? So then it is now at the noble gas configuration. Okay, so it loses a negative electron, so it becomes positive. It is a positive ion. Down here you can see positive ion. Now, does the removal of an electron from a neutral atom, such as this one up here, does it require energy or release energy? Look at this arrow right here. This arrow is pointing towards the atom. That means that you have to put in this much energy. So 498 kilojoules per mole, you are putting in this much energy to be able to pull that electron out. Now, with your periodic table, remember the left-hand side are the metals. The right-hand side are the nonmetals. We are first going to talk about the metals. Metals are reactive because they need to lose valence electrons. It's easier for them to lose them than to gain. So remember, we had talked about on top of group 1, we had a +1. Okay, so it needs to lose one electron to be at a noble gas configuration. Group 2 is a +2. It needs to lose 2 to be at the noble gas configuration. Now we look at transition metals. Transition metals, remember, are going to have different rules. Transition metals have outer energy levels of, remember, N is the period, and then S2. They do not generally form ions with the noble gas configurations. Okay, they're going to lose their S first, but remember, they can also lose the D. So transition metals commonly form 3+. And I am going to give you, let's talk about this first. Transition metals commonly form 2+ or 3+ ions, but can form greater than 3+ ions. Other relatively stable electron arrangements are referred to as pseudo-noble gas configurations. This can be kind of confusing, but I am going to give you a sheet of paper that is going to show you which particular ions we in this class will be working with. One of those will be iron. You can see here that iron can form 2 separate ions. So here's its configuration. And it can form either a +2 or a +3. And we're going to work with this more so that you will be able to understand. So realize that the transition elements can form more than one ion, and I'm going to give you a list of those. Okay, so let's go into the negative ion formation. Okay, a negative ion is an anion. So cation is positive because cats are positive because they can get mice for us. Anions are negative. Okay, this figure over here shows an illustration where chlorine gains an electron. Okay, so if you gain a negative, you become a negative. And you can see, look at this question down here. How does the energy change accompany positive and negative ion formations compare? So, do you have to put in energy or do you get energy out when you form an anion? And you can see that this arrow right down here is moving away from the atom, so it is giving off energy. Remember, when you form a cation, you have to put energy in. When you form an anion, you get energy out. Non-metal ions gain the number of electrons required to fill the octet. So, group 15, remember, was a minus 3. So it is going to gain 3 electrons. 16 was a minus 2. It's going to gain 2 electrons. 17 only needs 1 electron, so it's a minus 1. Remember, they're all trying to get to that octet. Oxygen gains 2 electrons to form what kind of ion? Yep, answer is a -2 anion. Remember, anions are negative, cations are positive. Elements with a full octet have which configuration? Answer is noble gas configuration. Okay, that's all for section 1.